Sodium chloride can be converted back into its elements. Dutch National TV has produced an excellent video of this difficult experiment. While I'm fluent in chemistry, I don't know any Dutch, but I'll try my best to ad-lib my voiceover translation. This experiment is the electrolysis of table salt, sodium chloride. This coarse tube is filled with sodium chloride and it is being heated with a gas burner. You can see the sodium chloride is starting to melt. Finally, the ionic compound is completely molten at 800 degrees Celsius. The fire bricks behind the tube are glowing orange-red in the heat. Next, metal electrodes will be attached to this DC power source. The left non-reactive graphite electrode will be the anode, where electrons will be removed, oxidation. The right non-reactive electrode will be the cathode, where electrons will enter, reduction. The electrodes are inserted into the molten NaCl. The circuit is closed. And the current over 3 amps starts to flow. Bubbles from the anode can be observed. The gas from the anode is collected in a container next to the electrolysis cell. The pale yellow-green gas is chlorine. At the cathode, the blue at the very start may be free electrons, which react with the sodium ions to form molten sodium metal. On cooling, the tube is broken and you can see the solid sodium dispersed in the unreacted sodium chloride. You start with a half a cup of salt, 117 grams. The electrolysis of this 2 moles of NaCl would result in the reduction of 2 moles of sodium ions into 46 grams of sodium metal, 2 moles of metal, and the oxidation of 2 moles of chloride ions into 1 mole of diatomic gas, which has a mass of 71 grams. With 117 grams of salt changed into 46 plus 71, 117 grams of product, mass is conserved in this reaction. Energy was conserved in this reaction as the energy from the battery was converted into potential energy in the sodium and chlorine gas. This reaction is endothermic. Kinetic energy from the battery converted the NaCl, the salt, into sodium and chlorine gas. This kinetic energy is now changed into stored potential energy in the products. 2 moles of sodium metal and 1 mole of chlorine gas have several thousand more kilojoules of stored chemical energy, enthalpy, than 2 moles of sodium chloride. The sodium, metal, and the chlorine gas have the potential to release that energy in other chemical reactions. The sodium ions have strong ionic bonds holding the particles together. They have very few possibilities of forming stronger bonds in other reactions, but the energy from the battery broke these ionic bonds, and the elemental forms that resulted in this endothermic reaction have weaker bonds. The sodium and chlorine have potential to release energy in forming stronger bonds as they react. You don't need safety glasses when you dissolve sodium chloride in water. It doesn't have that potential. But stand back if you add sodium to water or are around chlorine, which is also very reactive.